Hello, ladies and gentlemen. My name is Nicholas. Here with me is Matthew and Tyler, and we are part of Novita Medical Innovations, and we're very excited to be sharing with you our capstone design project. To understand the problem and our proposed solution, we first need a bit of context. Our problem is directly associated with the ventral hernia repair surgery, specifically with a tool called the spatula. A ventral hernia is when the intestines push through the abdominal wall, creating a bulge that can range up to 20 centimeters in diameter. Our team is focusing on the open hernia repair technique as seen in the video. For this, you'll need to place and secure a surgical mesh inside of the abdomen. This will be done using a suture passer and needle in coordination with a tool called the spatula. The spatula is the root cause of inefficiency. With the spatula, the surgery can take up to 3 hours to perform, requiring at least 2 physicians to coordinate each pass of the suture for up to 42 separate puncture sites. Each puncture site has the potential to cause a bowel perforation, which will result in the immediate abortion of the surgery. Our client had told us of a patient that previously had a failed ventral hernia surgery, resulting in a severe abdominal infection, requiring 5 additional repair surgeries over the course of 7 years. This example shows just how dangerous and complicated a failed hernia surgery can be. For the solution criteria, the function of this design of this device is to provide a puncture-proof barrier for the abdomen during mesh insertion. The objectives and key constraints of the design are to be thin, disposable, biocompatible, and puncture-proof. With our project, we're looking to update the open hernia procedure by removing the spatula. This will be done by using a retractable device that sits beneath the surgical mesh, eliminating the risk of missing the spatula with the suture passer entirely. The retractor method only requires one physician to operate. It will cut surgical time by 1/3 and reduce the chance of operator error. The benefits of this device not only come from the safer procedure and the obvious cost savings in the OR, but the potential applications in developing countries. There's a need for affordable surgeries in the developing world. Our device can have a large impact on these developing countries.
For the design process, we started by referencing Dr. Luau's patented string leaflet design. It was a great idea, however, it lacked proper engineering and design. Being difficult to deploy and made from inferior material, we improved upon this design while working within the patent. Using the spatula and Dr. Luau's prototype as a benchmark, we then used various methods to solve an optimization problem that involved the leaflet's shape, a better retraction and deployment method, and a way to evenly distribute these leaflets. This left us with 3 main designs. Using various ranking methods such as a weighted design matrix and physician consultation, we were able to evaluate our 3 main designs. With the string leaflet design, the sutures could get caught in the strings, causing major surgical issues, making it not a good option. The syringe retractor was not viable as it contained too many complex parts, which made it difficult to use and manufacture. This left us with the turn knob as our main design choice. From the CAD model, we went through several design iterations and developed it into a working 3D model, as you see on the right-hand side. This turn knob design consists of 3 main parts: the turn knob, the 6 leaflets, and the bottom clamp. All of these parts will be machined from PTFE Teflon plastic with a total thickness of 12 millimeters, which is less than our 20 millimeter design constraint.
Once we had a functioning prototype, we set up a demo surgery using synthetic skin and muscle tissue layers with balloons being used as intestines. In this way, it would be very easy to determine if any surgical tools had passed through or around the retractor because the balloon would simply pop. Once the incision is made, the retractor is placed in the abdomen. The small retracted size of the tool allowed it to be easily inserted through the incision, and the design allows for quick deployment. Removing the device is just as easy. Once the mesh has been loosely stitched in place, it can be pulled to the side so the retractor can be collapsed and removed. With the retractor in place, there is complete protection of the surgical area. Tools and sutures can be placed wherever necessary without having to worry about puncturing the intestine. With Teflon having a tensile strength of 34.5 megapascals, surgeons can be completely certain that there is zero risk of puncture. The design also ensures that there is no gaps between the leaflets. Completing the surgery using the spatula is a tedious and time-consuming process. Aligning the suture passer with the spatula takes almost a minute. This process is repeated over 40 times in some surgeries. When viewed from underneath, it becomes clear just how small of an area there is available and how easy it would be to miss the spatula. With the retractor in place, however, inserting sutures becomes a simpler and less time-consuming process. The surgeons can focus on efficiently and accurately placing the stitches and completing the surgery without wasting time repositioning the spatula or worrying about puncturing the intestine. As you can see while viewing from underneath, a relatively large amount of pressure can be applied that gets distributed evenly with no worries about puncturing through the retractor. Moving forward, we will continue to work with our clients, refine our manufacturing process, and begin clinical trials. In the future, we hope to find veterinary and other surgical applications for this device. Thank you for listening.